thank you very much for listening into this talk that I'm giving right now. So, first of all, before I start, I always said that this is probably the most important slides. Well, this is like applied to when I'm giving a live talk, right? Because people will be like, putting the phone and then taking pictures and stuff. But so I always said that like with this slide, you don't need to worry about that because all the slides will be on slides.com at the link at the bottom. But since this is probably recorded, so maybe there's less worry about people have to be distracted themselves with taking picture of the slides. So without further ado, I would move forward and go ahead. So do you know what is GIL? So usually I ask people to show a show of hand. Do they know what is GIL? So I have a better idea of like, what the audience know and what they don't know. I guess you can like do it now on the chat if you want to, but you're not required to to do that. And also there are delays and stuff. But don't worry, I would make sure that everybody is on the same page, and I will explain a little bit of what is GIL and why we care about this in a bit. But before that, I would like to introduce myself. So I'm Cheuk. I work for Alaconda. So it's really, really exciting to be here and talking to you all through this like amazing online technology. And also I love open source project. I involved in lots of open source project in the past. Those are in the past. Right now I'm actually like helping a lot of people to understand more about like what they can do with like using other tools to make their data science life much better. Also I love the community. I've been to a lot of conference, speaking at a lot of conference and organized some of them as well. So yeah, if you meet me in person in the future, please come say hi. I really appreciate that. I love talking to people. So yeah, so come to talk to me. So like I promised, I'm going to make sure everybody know what is the GIL. So I'm going to talk about that in a second. So what is a GIL? Like, what is that stand for? Like, well, I put it all capital here. So it probably is like GIL is, something that's the initial of some terms or words, right? So it's actually stands for Global Interpreted Lock. So Global Interpreted Lock is something that is quite unique in Python. Because in Python, for those of you who don't know, so in the computer nowadays, especially if you kind of, let's say you buy a new computer, it says like, oh, you have how many cores that you have, right? So right now, recently, there's Black Friday, and I go to like look at Apple Store and like looking for a new laptop for myself, and I see like now, the newest model you can get like 8 or 10 cores. So it's like, wow, a lot of cores. So what does that mean? So that means that a lot of process in your computer, if it support multi-threading, that you could actually not just use one CPU, but multiple CPU to get the job done. So wow, it's like, in a project, if there are more people working on it, so it may be like, it will get the job done faster. But the problem is that, it's like teamwork. You have to really like have a very good design of how people can work together, how this like, CPU could work together, but not like tremble on other people's toes. So in Python, things are a little bit complicated. So by design, right? By design, so Python will have this global interpreted lock. Basically, is locking that the whole Python itself is going to be only one thread's going to work on Python. So when Python, so like, because actually Python is also a program, if you don't know, that if you download Python, actually Python is a program that read your Python code and then will just like carry out the instructions like, from your code, right? So the global interpreted lock basically makes sure there's only one thread that's going to read your code and execute the code. So there's no tripping on other people's toe, because things can get messy if there's more than one thread accessing your program. So yeah, only one thread can be accessed. So I'm kind of ahead of my time and already talked through this point. So things get messy when there's more than one thread that actually work on your code, because a lot of Python objects, they are mutable. They are actually like, for example, dictionary or list. Imagine like sometimes, if you have multiple threads and they can get mixed signal, right? Because you may, you assume that your Python code is like, if you're not writing async or any code like that, it's just like, execute one instruction at a time. But imagine if like, two threads getting two instructions and they're trying to change one object together at the same time, weird thing can happen. So we don't want that. We will want the log to make sure that our program run just like what we're expecting. So that apply to Python. So Python, the solution of Python, like now with the standard distribution of Python, the solution is that we have this global interpreted log. So it's only one thread is doing the Python thing. So it's like no other thread. So the other thread can do other things at the background if you have multiple things running in your computer. But for Python, only one thread is going to do that. So other, but that's not the only solution. That's what Python is doing. For other programs, other computer programs, they may actually support multi-threading, so that they actually like may have multiple thread running that process or running that thing. So it's not it's not something that like we absolutely cannot do. So that's why we bring up to this talk. So there's a no-GIL version of Python. So what does that mean? So this no-GIL version that I'm talking about today is especially one version that I'm talking about is a clone of Python 3.9. I know, like now because now we are in 3.11, it sounds a bit old, but it's okay. Just trust me. Just I would talk about that in a bit. So this is actually the newest attempt to remove the GIL, so to have no GIL Python. Actually, there are previous no GIL Python version that is done by other like very smart genius people in the past. They have all tried to attempt to remove the GIL in Python, because we want to try something that maybe can make Python faster. But this version, the newest version, is done by Sam Gross. He's also a genius. He's like, he gave a talk in EuroPython this year. That's why I was inspired, and I want to like, try it out myself and kind of discover what it's about. So, well, again, like why we're talking about no GIL, right? Why it's like Python is okay right now. It's like okay as is. Like why do we want to remove this GIL that is supposedly being useful and make sure that Python is doing its job? Well, the thing is that since, like I said, now we have computers that have multiple cores. Imagine if you have a very, very heavy Python program, and now you have 10 workers in your computer, and you are only assigning one worker to work on your very heavy Python program. What if I can assign the 10 of them work together to just finish my Python program, so I don't have to sit there forever, right? So that sounds great. So now, since like you just go to like some other like just get a laptop, you have like multiple core. So we want to make use of that, to make use of the speed that it would benefit us to run our Python code faster. But things are not that simple, right? It sounds really good, but it's not that simple, because there are a lot of challenge if we try to remove the GIL. There's a lot of, it's not that straightforward that if we say, okay, let's remove the GIL and everybody's happy. No, it's not that. First of all, something that we need to care about is that if we remove the GIL, right, we also make sure that for people who are still like using a single thread, they are not going to be losing out, right? They are not going to be like we sacrifice the performance for people who are using single thread but only like optimize performance for multi-thread. No, that's not something that we're doing here. We've got to make sure that it will be fine for people who are just like prefer to have the lock, right? It's also fine. So we just like have an extra step that makes sure that if we're doing multi-threading, it's supported. So there are lots of things inside Python, how Python work, that basically need to deal with before we remove the lock. For example, there are the reference counting. So reference counting is in Python that when you have a lot of different objects that got created in the Python execution cycle, right? So when something is created, some memory is assigned to do this job, or to store this object, this value in this object. So in Python, there's also like we're counting, like whether this object is still needed, how many other objects are referencing this. So if nobody's referencing it, maybe it's not useful anymore, then we can remove it, right? So this reference counting get a little bit tricky when you have multiple thread, because we are not having one thread that is accessing and like managing all this access of object. There are multiple, so there's like something that it could be a little bit tricky. So there's a new thing called bias reference counting that was introduced. Also, like some objects that now are like basically instead of doing very complicated reference counting because we have multiple thread, we just make them immortal, which means that they will be there forever until the whole Python program is finished executing. So those things usually are the most commonly used object, like true and false. We use that a lot because we, if you have written some Python code, you know that we have a lot of if else. So true and false is quite commonly used. Also, some integers, some smaller integers, they are also like quite commonly used. So those objects, it will just be there. We will just have no reference count and make them immortal, so they will be there all the time. There are also some other things that, like for example, some global functions that basically, because it's kind of at the top level, so the reference count is going to be handled separately. It will be dealt with before the garbage collection. Garbage collection is the step that when the objects there's no reference count, so basically they can be recycled, so they are not used anymore, so we do the garbage collection. So that's the stage that like some objects will be dealt with when it's the time for the garbage collection. So yeah, right. So design and challenges. So now again, like for those are the things that, like, few things I talk about about the reference counting and the garbage collection. But there's also other things. For example, if I have multiple threads, they're trying to access the same object, right? Like I said before, a lot of objects in Python is immutable, so things can be changed after they are created. So what if two threads try to change at the same thing? In that case, instead of using a global lock that locks the whole program can be only accessing by one thread, we have to have smaller locks, which means that I always put this analogy is that instead of, for example, the global interpreter lock is like you only have one driver driving the car through the whole road trip, that you only have one dedicated driver and there's nobody else going to touch the steering wheel. But now it's not like we have actually two drivers or multiple drivers in this road trip that we're going to take turn driving. But we have to have an agreement that, like, okay, when someone's going to hand over the driving wheel, right? In a car, it's very easy. It's physical. You just you just stop by some kind of, let's say, gas station, and then, the driver step out of the car and then sit in the other seat, and the new driver come into the driver's seat, right? So that's very obvious. But in a program, so we need to have other mechanism to change driver. So this is how we have smaller locks. So only one person is going to touch the steering wheel at a time, but this steering wheel can be passed around to different drivers. So this mechanism needs to be written in the CPython itself, because right now how CPython work is that yeah so I'm just reading the comments, sorry. Right now, when we, for example, use the standard version of Python, it's called CPython. So inside CPython, there's a lot of CPython API that was written. Basically, is that when Python, so to put it simple, so when Python, the program see that line of your code, it will get interpreted as like, okay, I'm now doing this. For example, I'm doing a if else, so I'm going to call this C code that actually do the same thing. So, and this is how Python is interpreted right now. So with this new design, we have to also have some CPython API that basically, when we interpret the code, we see that, okay, now we hand over the driving wheel. So we need to write that down as well. So that's basically means that more work needs to be done, not just that simple. Also, there's something in Python right now that's called PyMalloc, which is a allocator of resources, and we're like, this is what Python is using now. But if we are thinking about changing how Python work by removing the GIL, we have to use a new lock that's called the min-malloc. It's designed by Sam's team, his colleagues to develop. I think he works in Meta, so it's like this is an open source technology that's developed by Meta. So for more detail, you can listen to his talk and other resources that I will mention at the end. So I'm also for the garbage collection is also, because when we collect the garbage, we make sure that nobody's gonna try to access it again, right? So when something is ready to be collected, like when we thought that nobody's gonna using it, we're gonna have to stop everybody from actually accessing it. Otherwise, like we thought nobody's using it, but suddenly someone's trying to use it, then it's gonna have a conflict. So I need to stop the world for garbage collection. So there are lots of new things that actually need to be considered, and I'm just touching the surface right now and briefly explaining what's going on. I'm not going into detail here, but if you want a detail, I would point you to the right resources at the end. So don't worry if you think that, oh my God, there's too many information, I don't know what you're talking about. It's fine. I'm going to point you to the original talk by Sam and you would understand more. So they are all like kind of introduction of what's going on and why I'm doing this. Now is like what fun I have when I'm trying it, right? So after I've heard this sounds really good fun, and I really want to try it with the thing that I do as a data scientist. I was a data scientist, so I do a lot of this kind of thing. I want to see if this is going to improve the scientific program. So, I have my doubts because for those of you who use let's say SciPy or NumPy a lot, you know that in those packages we already have a lot of optimization done. That is, we are not just running pure Python code when we are using those packages. In those packages, we already have a lot of a CPy module, which is like, if you look at the source code, there are some file that is actually end with .cpy, and those are actually written not in Python, it's written in C. It's kind of like a plugin to make things fast for those kind of code. Also Python is also another tool to compile some of the code that to make it fast when you execute your code. So those are already used behind the hood for those like SciPy and NumPy and scikit-learn. So we already have a lot of optimization. So does this nogil really help us more? So let's try it, right? So you never know until you try it. So I'm going to give it a try. So I'm going to test it on some popular scientific process. So that's how I design my quote unquote experiment, right? So it's not very scientific, but it's kind of a little experiment or a little fun that I had. So I want to try on something that's like scikit-learn. I want to try on something like NumPy and SciPy. So those are the most popular Python library. So I want to try on some neural network, but unfortunately, because like I said, this library, they are having some kind of external library, so it's not on pure Python. They need to have a build that is matching your computer, right? They are compiled. So for the nogil version of Python, for scikit-learn, NumPy, and SciPy, those are available to use. So this is brainless. It's like straightforward. I just like use those to do my testing. But for other libraries like TensorFlow or PyTorch, it's more complicated, and I can't get hold of a version that basically work on the nogil, so I kind of haven't done that yet. So maybe I'll do that in the future. Who knows? So also, again, like disclaimer, my experiment is not very scientific. So if some of the result, it doesn't actually absolutely represent anything. It's not a conclusion. It's just something I hope to spark some interest or some thought about it. So so let's have a look. Also, by the way, I compared the nogil version, the original 3.9, which the nogil version is cloning from, and the newest and shiniest 3.11 version of Python. So let's see. Oh yeah. By the way, all the code are also on GitHub. So if you have this slide deck, you can click on it and find the code. But all of them are just like example that I copy from the official documentation website from scikit-learn, NumPy, and SciPy. So you can find them and do it yourself. So for the first one I try is the support vector machine, because usually it takes a lot of time for my code. So I download this example again, like from the official documentation of scikit-learn. Is using SVM to recognize some handwriting. I run each of them around 50 times, try to average the time, so it's kind of a little bit more smooth, because you know every time you run the program there'll be like slight discrepancy depending on what's going on in your computer. So I average it over 50 times to get a more stable kind of measure of how fast it is. So you see that actually there's no significant difference in this three different version. Oh, by the way, I was running this on my old MacBook, which is quite old. It's only got dual core. So again, like I said, I'm buying a new one, so maybe I can test it in a new computer in the future, and there will be maybe other results that is different from this. But so far for this like old MacBook with only dual core Intel processors, it's like no difference for the SVM, which is a little bit disappointing. So, but I continue, right? So again, this is not a conclusion. This is just a start of trying it out. So, I try another one for the clustering. So clustering this, I use again another demo from the scikit-learn documentation, and then I found that again, there's no significant difference between all this different clustering with k-mean or PCA. These are usually very like heavy processes, but of course the example they are more lightweight rather than your real computation will be more heavy. But still, there's like no significant difference, so it's a bit disappointing. And decision tree is like very interesting, because actually the 3.9 is the fastest. I don't know what happened, but actually in the decision tree there's a lot of like randomization that's going on. So maybe it's just that I got lucky or unlucky. I don't know how you can frame it, but is not so like you have a range of actually the result, because again decision tree is like randomized, so it's a bit difficult to compare. So yeah, again, I don't see there's an improvement from the nogil, which is a little bit disappointing. So for the linear algebra, actually this one, the nogil version is actually better than the CPython 3.9, which is the original version that is cloned from. So it's a linear algebra on the n-dimensional array. So the example is actually doing some kind of image processing, filtering on the image. And you can see that, so for this linear algebra, actually nogil is better than 3.9, but not 3.11. So still not the ideal situation that I want to see right now. Oh, sorry, that was linear algebra, and this is like so this is so it's like some norm and transpose. So I think this is in the SciPy, in the SciPy. So it's like the thing, and I get it mixed up with this image filter. So this image filter is actually image processing on the NumPy arrays. So they applying some Gaussian filter and stuff to, so it's kind of doing some image calculation with like different there was a grid of of numbers, and it do some calculation there. So it depends on the filter. Actually, the result varies. So for the nogil, you can see the improvement in the Gaussian filters, but for the other filters, actually, different standard version of Python perform the best. So yeah, so the again, like the result is not conclusive. This just spark some kind of debate, I guess, or interest into like people trying it, or you can try it in your machine, which probably be better than mine, and to see if let's say you have 8 core, maybe it'll be better. I don't know. So the last one is again so I said I want to try it on some neural network. So I can't try on TensorFlow or PyTorch, those popular ones. So I'll try it on the on one that's provided by scikit-learn. Actually, is not it's not too bad, because MLP classifiers, scikit-learn also provided that. So it's a stochastic learning. So you see that actually again 3.9 is the best amount of them. Is only average about 10 times, because this learning process is a bit slow. So 50 times it will take me ages to finish. So so all of this result again like is not conclusive, but it's a bit disappointing. So what happened? So along this journey, I asked myself it not as fast as what I wanted to. There are a few things that I was thinking about. So first of all, there are actually discussion about this new version of nogil Python last year. This year actually, in PyCon US, there's like a maintainer summit. So they have discussions. So I have some notes which I will also show, as a reference at the end. So the thing is, like, this nogil version has done a lot of improvement, but the thing is that you know uh, the library that we are using for, like, for example, scikit-learn or NumPy, they are already having the C extension improvement. So those are not necessarily affected by the GIL because they are kind of pushed outside of the Python system. They are already like compiled, and they were written in C code and got compiled. So they may already be using multiple thread, and it's already quite fast. Also the interface that this C extension talk to Python, it may not be the most efficient right now because it may still expecting the GIL. And so eventually, if this no GIL kind of strategy got adopted in C Python, the whole thing needs to be redesigned to adopt this no GIL mode. So that may actually become an issue or a block to have like this no GIL design that is adopted as the standard version. It will still take quite a while to get there, I think. Also compatibility, so it may not, it's working, it's like running the program fine, but it may not be optimal because again, it's the extensions are not expecting you running it on a no-GIL Python. Also, my experiment result is not a very good conclusion because I'm running it on dual core machine. So if you have more core, if the parallelization will help in the speed, then it will be easier to see if you have more core, because if the design is good, then you wanted the improvement to be close to linear improvement. So the more core you have, the improvement should be more obvious. So last, this is still a work in progress, and so we should not treating it as the conclusion of like whether it's useful or not, because
Hello, Cheuk.
people are still
Sorry,
working.
now we'll have to
So
end the session now to
yeah,
take
we're at
questions
the end
and
of the
answers.
session. Can I
So,
have like just 1 minute to close it up? I'll just close it
okay,
now.
the
Yeah,
next talk, the next speaker will enter the room, will enter the session. Now we have just only 20 seconds.
Yeah, so this is actually the last slide, basically. It's the reference. So if you get the slides at the beginning, you would actually have all this link, and you can check out the talk by Sam. There's like more detail on there, and also the blog post by Lukasz, which is one of the C Python core maintainers. So there's like more discussion about, whether C Python will adapt no GIL. There will be discussion there, so check it out. I think that's it.